A sunspot has grown so large that it could have catastrophic consequences. The size of sunspot number AR3664 is increasingly resembling the Carrington sunspot, which in 1859 was the harbinger of an apocalyptic particle storm that put the USA in a state of emergency for weeks. The gigantic spot, which can now be seen on the surface of the Sun, is already 15 times wider than our Earth, at 200,000 kilometers in length, and will probably continue to grow. Does this mean that the event of 1859 could happen again, and our entire civilization could collapse within minutes? AR3664 is one of the largest and most active sunspots in the current solar cycle. Sunspots are areas on the surface of the Sun caused by intense magnetic activity. These spots appear darker compared to the surrounding solar surface because they have a lower temperature. Typically, sunspots are about 1,500 Kelvin cooler than their surroundings and can reach diameters of several thousand kilometers. On average, sunspots have a diameter of around 16,000 kilometers, but AR3664 is already exceptionally large at almost 200,000 kilometers, more than 15 times larger than Earth. If the spot continues to grow or does not slowly disappear again, we must expect repercussions that could lead to a catastrophe on a global scale. Solar storms have the potential to bring our entire modern civilization to a standstill within minutes. As a result of solar flares and coronal mass ejections, where large amounts of plasma and magnetic fields are thrown into space, powerful geomagnetic storms can hit the Earth and destroy power grids and paralyze communication systems. AR3664 has already produced several such flares, which released enormous electromagnetic radiation and even led to bizarre light shows in the atmosphere on Earth. In early May 2024, auroras, which are otherwise only visible in the far north and south of the globe, appeared in regions where these phenomena do not normally occur. We have still been spared the truly fatal effects, but can we be sure that it will stay that way? The sunspot is visible to the naked eye. Imagine that the Sun is many times larger than the Earth. Average sunspots are usually tiny compared to these dimensions, and we can hardly see them with the naked eye on Earth, especially since it's not really advisable to look at the Sun with an unprotected eye, for which the consequences can even be loss of vision. AR3664 is different. This spot is already so large that you can see it with the naked eye, protected by specially certified solar eclipse glasses. The best time to observe sunspots is during the daytime hours when the sky is clear and the Sun is high in the sky. Places with clear skies and low air pollution from particulate matter or other atmospheric opacities offer the best viewing conditions. Sunspots like AR3664 are actually quite normal in the cycles of our Sun. They are caused by intense magnetic charging and convection processes within the Sun, where hot plasma masses rise, cool, and sink again, creating and twisting strong magnetic fields. If they occur in such an unusually large size and activity as AR3664, this could indicate a particularly strong magnetic field concentration in these areas of the Sun. Such sunspots are rare, and we need to know more about them, because we have become extremely vulnerable as a civilization. A strong solar storm like the one in 1859 could have a very different outcome this time. 1859, the Carrington Event is a warning. Can you imagine how an entire nation thought for a few hours and days that God's judgment had fallen upon them? When people in the USA looked up to the sky at that time, they saw a burning sky. And many people really just thought that God's wrath and a burning judgment was coming from heaven. At the same time, the few electrical systems that existed at the time were sparking wildly. Telegraph poles were hissing day and night, and the communication networks, which were in their infancy at the time, were paralyzed. Nobody knew what had really happened. It took weeks for the news to reach the last remote settlements of the Midwest and the loneliest stretches of land. Only one man interpreted the events correctly at the time. The Briton Richard Carrington was absolutely right to discover a darkening on the Sun. Carrington suspected that a huge solar storm had reached the Earth and that the electromagnetic charges had penetrated the Earth's deep atmosphere, causing problems with electricity and magnetic equipment. The Carrington Event peaked on September 1st and 2nd, 1859, but the aftermath and fiery skies lasted for weeks. The USA was particularly affected, but the effects were also felt elsewhere. Some telegraph stations in the U.S. were able to continue sending messages even without batteries connected, powered only by the geomagnetic storm. Elsewhere, the charges were so strong that electric shocks leaking from the telegraphs set paper on fire. Imagine, at a time when there were hardly any means of communication, just a few telegraphs, newspapers, stagecoaches, or messengers to spread news. The fastest means of communication broke down, and it took ages for the news of the solar storm to catch on. The sunspot that Carrington observed was exceptionally large, although the exact dimensions are not documented. The eruption he saw was a massive coronal ejection that hit the Earth in just 17.6 hours. The Carrington event was relatively mild at the time because humanity was nowhere near as technologically advanced as it is today. Once it was clear that it was a natural spectacle, people back then could also enjoy colorful auroras. The auroras were even visible in Cuba, Hawaii, and Queensland in Australia. In our time, if we transfer the scenario to today, the danger quickly becomes clear. Events like this huge flare can bring our power supply to a complete standstill. If power grids collapse, all systems that rely on electricity will collapse within a few days at the latest. Emergency generators could help out with fuel for a while and provide emergency power to important systems, such as banks or food-producing companies. But if such a storm lasts longer, things become bleak. Imagine masses of food rotting because refrigeration systems fail. ATMs go on strike because there is no electricity. Even petrol stations no longer work because these distribution systems are now predominantly electricity-based. Your cell phones would no longer work, the internet would be unavailable, and the TV screen would remain silent, as would the radio. There might be sparks from sockets, fires would be the order of the day, and those affected would no longer even be able to call the fire department. Satellites, which are essential for communication, weather forecasting, and GPS navigation, could be damaged or destroyed. This could result in dramatic outages lasting weeks or months. Aircraft navigation, ships, and car navigation systems could fail, and accidents would be inevitable. A study by the National Academy of Sciences estimates that an event of the magnitude of the Carrington event today would cause damage of up to $2.6 trillion USD. In the USA alone, the damage could plunge us into a global crisis, drive countries into bankruptcy, and ultimately lead to the collapse of our entire order. And now imagine, such a stream of particles could hit us at any time. AR3664 is just the beginning. I bet you didn't know that AR3664 has already produced M-class and X-class solar flares, some of which have hit us. The flares occur when the magnetic fields in sunspots twist and shear over each other, suddenly releasing large amounts of energy. On a logarithmic scale from the National Oceanic and Atmospheric Administration (NOAA), solar flares are classified as A, B, C, M, or X-class. M-class flares are 10 times stronger than C-class flares, but less intense than the most powerful eruptions, the X-class flares. M-class flares can cause short-term radio blackouts in the polar regions and trigger small geomagnetic storms, which sometimes lead to visible auroras. With X-class flares, we are already dealing with the strongest solar flares. They are at least 10 times more intense than M-class and can lead to severe outages if they hit us with full force. The good news is that the really violent flares have so far passed us by, so we have been lucky. But according to researchers, it's only a matter of time before a violent X-class flare hits us and puts our global security to the test. In fact, surveys have shown that hardly anyone on Earth is aware of the danger. Strangely enough, when respondents are spontaneously confronted with the idea of a strong solar storm, most say they still feel safe. This is because a devastating solar storm has never occurred in our modern civilization. People have no internal standards for the scale of the potential problems and consequences, so they feel safe. The fact that tiny invisible solar particles can be so dangerous to us is underestimated. The first thing we need to know in order to protect ourselves effectively is the fact that it can happen, and at any time. If your electrical equipment stops working in the morning, sparks fly from sockets, and the sky is on fire, you'll know what has happened. You can also protect yourself from threats like these by always keeping an emergency stock of food, clean water, and money at home. If supply networks fail, you should be able to get by without shopping or money for at least a week. Monitoring the sun to save civilization. Of course, researchers and governments around the world are also trying to protect us. The first measure is ever better monitoring of the sun. When spots like AR3664 appear, global observatories issue warnings to institutions such as governments, airlines, satellite operators, and electricity companies. International cooperation is taking the problem seriously, and experts are trying to develop strategies to protect our global infrastructures and power grids against flares and their effects. In practical terms, these include improved power line facilities, resilient satellites, emergency communication networks, and technologies that can deal with strong electromagnetic fluctuations. The NASA Solar Dynamics Observatory, or SDO for short, is one of the most important facilities for monitoring the sun. Since its launch in 2010, the SDO has been providing high-resolution images and data on solar activity around the clock. It continuously observes the sun at different wavelengths of light to provide an even better picture of events, such as solar flares and coronal mass ejections. Thanks to the intensive monitoring of the sun, maps of the sun have been created, and we understand the cycles and rhythms of solar activity better and better. This should make more accurate predictions and forecasts possible. By analyzing this data, scientists can now also better predict the probable development of Sunspot AR3664. Nevertheless, the question remains as to whether this can really protect us in an emergency. The sun can spontaneously generate a flare, and it can reach us within half an hour. How much time would there really be to land planes and secure power grids? Subscribe to the channel now and be part of every new video.